the actual CT data. We're not using a model yet. So the only thing we have done is extract what part of the data we want to keep. Now, in this case, I want to make a smooth surface. Yeah. And that basically is one of the tools that is often already being done in post-processing. The moment I have a smooth surface, you see it highlighted like this. If I create a detailed surface, yeah, it is basically using the exact information in the scan. So this is the real data, but because scans are often slices, or unless you're using ultrasound data, it means that you see sort of a staircase pattern on the model. If you can look very closely, you will be able to see little steps there. And that is because the data is built off of a slice with a distance between the slices. When we use the smoothing part basically erases that and creates a transition between the two. So smooth. Yeah, that's the main difference between the two. Now, one of the great things we can do with this is to show this in the model, in the data. So in this case, we're now back to the normal data set, yeah? But we also have that 3D extraction in here. So suddenly we're capable of using that in a different way. Now, this was the visualization basically on which we based this kind of extraction. But of course, we're also capable of showing it in a different kind of visualization. And that allows us to basically see different things at the same time. For instance, again, using it in an area environment, and suddenly we see how that is related to other parts of the data. Well, in this case, it's blue on blue. I don't like having blue on blue, so I'm changing the color of my extraction. And suddenly we have that kind of information on top of each other. That kind of tool gives us a lot of freedom to have multiple ways to understand this kind of data. And there is Vesalius is a very important tool for operation planning and patient discussions, because it's so easy to understand how things are being done. Now, one of the things we like about this kind of tool is we built this because we got the question from one of the academic hospitals here in the Netherlands that they came to us and they said, well, you guys from PS Medtech Vesalius 3D, you have such beautiful 3D visualization. Now give us the Control P button, because we want to make 3D prints out of it as well for our planning and for our discussions in the hospital. So that's what we basically did. And from there on, this program was further developed. I think, Arjen, if you're in the session as well, you wanted to show how easy it is to make an extraction for someone who is less proficient with it.
Right, like myself. Thank you, Mark. Can you lower your volume, please, and also get rid of your presentation? Thank you. Let me share my screen over here. I'm going to present, and I'm going to present Vesalius over here. And just does anybody, do you see my screen, my Vesalius screen?
Yes, we see it now.
Okay, thank you very much. Just the ease of use where I would like to go over, because Mark is an expert and he can talk real easy because he's been doing this, I would almost say all his life. But I'm less experienced, although I've been with him for a long time. The moment you start with Vesalius, and I would like to put it in a little bit broader perspective. As was said before by Stefan, I mean, we read DICOM images. So DICOM, that can be any type of data that is generated in hospitals, being MRI, for example, or CT, ultrasound, all that type of information can be read into Vesalius. When you open up Vesalius for the first time, I mean, when you open it after a day's work, this is the screen you typically get. You get what you worked on today? Well, you see I opened up a data set MRI pregnant, CT coartatio, and a cardio full volume. But of course, not of course, but we also have a data library where all the data is that you can have a look at. We have import DICOM, and we also have connections to PACS systems. So it's a very extensive tool that you can work with in many different ways. Opening up a data set is easy. It's just clicking. I'm going to show you, before I go into the 3D printing for less experienced people, I would like to show you a different data set, different data than Mark showed you. It's an ultrasound. And an ultrasound is, well, it's not as detailed as, for example, a CT scan, but you can see the type of information we get out of it. As I said, this is the type of information doctors are normally used to, right? The image you see here on the left-hand side shows exactly the same information. And I'm just turning it a little bit, and I'm going to hide this button. And it's just a matter of how you want to show it. And the way we want to show it, as Mark explained, is that we want also give you more of the structural information. This is a nice data set because it's not only 3D, but it's also 4D. And I'll try to get it pulsating. My machine is a little bit slow, especially for a data set that's not that big. But it's opening. Oh, it's really slow, Mark. So now it starts pulsating. So you can see the pulsating over here. And on the right-hand side, you still have your dynamic images, which you're used to in 2D. Let me open up another data set just to give you the idea of the whole thing. And that's basically where I want to go to. Although I think my machine is really slow, but let's see how it goes. I want to open up a coartatio, and I will show you again what 3D printing and making an extraction, how that can be done in a very easy manner. Reading the data, I think my machine is really slow. So bear with me for a moment, which gives me the time to explain maybe a little bit more on the menu structure that we have. You see all types of buttons here up front, here on top. If you look at this type of buttons, that's used to manipulate a data set when you are using a laptop or a computer like I am right now. The great advantage, and that's why I'm really happy that we are here together with Schneider Digital, is that we also have Visualisation 3D available for the PluriView. And the PluriView, in my opinion, is, well, best of both worlds. You can show 3D information in stereo, but it also gives you the possibility to use your hands. And there is nothing as intuitive as a human being's hands. When you're a little kid, you pick up something, you pick up a pen or you pick up an object and you're studying it using both your hands. And sitting behind a VR PluriView equipped with Visualisation 3D, you're exactly doing the same thing. So it's delivered with a tracking system, an optical tracking system, where you get two balls, basically balls with reflective markers. And you can hold these balls in your hand. You show them to the camera and make sure that they're inside of the camera. And by using one ball, you can manipulate the data set. You can manipulate this data set, do it with your left-hand side, for example. And then you have the other hand available to do all types of interactions. So slice through it, make it bigger, make selections, etc., etc., etc. And that's a very intuitive way of working with these data. Using mouse and keyboard requires a little bit more experience, but as you will find out when you start using Visualisation, it's something that can be done also very easily. Which reminds me, and we shouldn't forget it, that everybody who's attending this session, we have a free license of the full version of Visualisation 3D available for you guys. You just have to leave your email address with us, and we provide you with a 3-month period where you can try it and experience Versalis 3D in your own setting, in your own hospital, and do whatever you want to do. Another thing that we are proud of as a company and that we always do, if you have specific questions and you want our help, our assistance, because you find some problems with a specific patient or well, whatever. We're proud that we always support our customers. And of course, it shouldn't take weeks, but an hour or 2 hours of our time, we're always willing to invest in our customers. So please bear that in mind. That's something we want to do. So this is, again, as I said, this is the type of interaction that you find with your mouse. So I can maneuver the data set from left to right. I can pick this little button and I can turn it around. And
Arjen?
Yes, go ahead.
We have in the discussion panel a question. Maybe you can answer it. Could you demonstrate for maximofocal region as well?
Mark, may I'm not getting the question.
Arjen, can I rephrase it? Maxillofacial. Do we have a data set of a skull that we can show today?
Right. So maybe we should let me go over my little presentation, which won't take too long. Mark and you guys can pick it up later off if that's all right. So let me finish this, just show the ease of use, and then we go into the specifics, if that's okay. Nobody's saying anything, so I assume it's okay.
It's okay.
Yeah, okay, thank you very much. So this is the way we present it. Again, this is the way you doctors are used to. You can slice through it, but we give you a 3D model. The power is, in my opinion, still, it's so powerful because we make all types of selections for you. We can show it, the area structures, for example. It's still the same data set as you see here on the right-hand side. It's the same data. We can combine it. So showing both the area structures, so the lungs combined with the heart and the aorta and everything that's there. Very, very, very powerful. But let me, because that's what this session is officially about. Again, we're here all day to answer all your questions and we want to make it more interactive. Let me go to the 3D printing. We have a near field plane, which I want to get rid of. And I want to move here on the right-hand side, the cropping plane, I want to get rid of as well. So here we have the data set, the complete in contrast. This little button is my power button. I love it. And why do I love it? I'll show you. Let's turn the data set a little bit around. Power button on, and I can change the level and width settings. Have a look what it does to the data. So basically, I'm going there slowly to, oh, my machine is, I should have restarted it. Sorry for that. But I'm working on a laptop, gentlemen, and everybody in the audience, ladies and gentlemen. Here, Mark already pointed it out, is a problem area, right? So I can smooth it up a little bit more. Let's say I am interested in this area and I want to have it printed. Again, I'm not the expert, but I want to get this printed. We have the extraction page, and I'll go through it quickly. I want to make a basic extraction. We get a warning. Never look at warnings, doctors. No, I'm kidding. No, but the first step in the process is the curve editor, which will be opening up. I have a slow computer. Here you see the curve editor, and this is the screen which you use to select the data set and the pixel intensity that you want to use. Here on the right-hand side, I'm moving it. You see, to the left, there is nothing changing. So I'm happy with that. Then I want to click over to the right-hand side and see if I can open up this thing. My machine wants to not responding. Beautiful. But that happens in live demos. Let me see if I can. Okay. I still would like to have this curve editor. I want to move that a little bit, show you what's happening over here. Say I'm happy with this print. Say this is what I want to have printed. Okay. I hit the button over here and I hit next. This is the best tool we developed in years. Honestly, this is the best tool. This makes people that are not experienced their lives very, very, very easy. It's called the scissor tool. Couple of elements, freehand, keep the shape. Keep the shape is a wonderful thing. So I hit the scissor tools. And now, which shape do I want to keep? I want to keep this shape. Shape is what I want to keep. Machine is working. This is what I want to keep. This is beautiful. Make some more selections. Okay. What do I want to keep? I don't want this. No, I want this to keep. So I go through it. This is what I want to keep. For example, we do it one more time. This is what I want to keep. Turn it a little bit more. And you will figure out the moment you're good at this, you have some more experience, or you definitely want to know, you know what you want to keep. You make your selections real easy, real smooth. Going to make one more thingy. I want to keep this. Get it out of the way, get it out of the way, get it out of the way. Okay, this is what I want to keep. So, say this is what I want to keep. Then I move to the next stage. Now I'm in the erase section. The erase section, you see this blue ball, which you can erase stuff. Just going over the panel, you can change the size of the ball, you can make it big, you can make it small, just to finalize the elements you want to print. Of course, people make mistakes. We have an unerased ball, it turns green, and you can unerase whatever you want. For easiness, I leave this out, but you can just make your model more refined. Then I'm at the last step. So this is the whole thing. I'm at the last step right now. Grow region. You see blue over here, and the elements of the 3D print you want to make over there. So I'm going to grow the region. You see this axis? You can bring it to your 3D model. Basically, it makes the selection then what you want to print. You can also do that here in this element, in the 2D screen. I hit this because this is the region that I want to have. And I say, I'm done. Look at the screen over here. Bam! You see it? It's cleaning the model. It's cleaning the model. And it gives you the 3D print, basically, that you want to have. So I don't know how long I'm talking right now, but it's not very long. Last element is you go into the surface, smooth the surface. And that's also a step where you can change the color. And I'll go into that, why you do that, of your extraction. So here is where you can change it. You can make it, for example, red or green or whatever. I take, in this case, a beautiful green element because it makes it clearer in what I want to show you yet last. And just for argument's sake, if you have a 3D printer and you want to have it printed, you can hit export. It comes Beautiful here. And you see over here, it's an STL file, which you can send to your 3D printer. You're done. You're done. So this is an easy way of making 3D structures. Again, everybody in the audience, if you do this in a PluraView equipped with Visualisation 3D, it's a very, very easy process because you're just using your hands. You're modeling, you're claying. Very, very easy and smooth. This is another button that Mark taught me, which is very powerful, in my opinion. You hit it. Here you see your original data set. So you have your original data set and combined with the selected area, the one that you can have 3D printed. You can go through it, you can have a look at it, you can have it printed, show it to your colleagues. You can show different visualization settings, show the whole surroundings. It's all about structural information. And there it is. Beautiful. Srihari, are you in the session as well? I know you want to record this.
Yes.
Are you in the session making some comments on the 3D PluraView, showing some of the elements I just mentioned?
Yes, I'm here.
Let me.
Am I audible? Hello?
Yes, your mic is on. Srihari, everything is fine?
Okay, cool. So I was just using our 3D PluraView while you were presenting. And this is the glass which I was talking to a couple of people before. This is so light glasses, and I'm also already wearing a glass. So most probably, like, you'll be having so much of disturbances. If you are having a spectacles precision glasses, then if you want to put a 3D glasses on, you can see how thin it is. There is no battery over here, so you can just, it's so big. And this is like Joseph was telling yesterday, that you can actually see people even if you are wearing this. And this is a polarized glasses, much more safer for a longer use. You keep it on the glasses, and still I can see you, the presentation. I can see Stefan, Joseph, Mark, Argen. So this is the monitor, and I'm seeing this beautiful data set in true stereoscopic. I'm sure that it is over lighted. Let me just move in here, and I'll switch off my lights so that I think. Okay, cool. So when we actually look at these images over here, it's much more interactive. And I'm also not from the medical field, but when Aryan and Arjun has told me about the software, we have trial licenses ready for people to use it.
Srihari,
It's much more. Yeah.
Srihari, you have to switch on the light in the room. This way the monitor is even brighter.
Oh, okay.
It's better in full light, but it's a very overexposed. It's better now, but it's still very overexposed.
Okay.
Yeah, now it's good. Now it's good.
Yes. So I was looking at the data sets in true stereoscopic. What is the advantage of the stereoscopy is about the depthness, how much depth you can see about the data set. With the right softwares like Vesalius, we can actually go and interact with the models much more better way than what we are doing. One of the advantage we feel, Aryan, if you agree with me, is that you can minimize the number of 3D printing that can be happened. You can minimize it because you can clean it. You can make the like you were discussing now.
If I may add to that, Srihari, it's a good point. Just from experience, we had customers that really wanted 3D printing and 3D printing only. And we remember that there is one doctor who was very much involved in it, and he wanted 3D printing because he wanted to have a look at it, and et cetera, et cetera, et cetera. And at some point, we created a 3D print frame, we gave it to him, but we also showed it within Vesalius on a screen. And he was looking at the 3D print, and then he looked at the screen. And he said, looking at the 3D print, and he looked at the screen. And then his remarks were, oh, but actually, I can see it even better at the screen now because I see the whole surroundings. I see the whole structural information. I not only see the problem area, I don't only see the problem, but I also see how to get there and how to start working on it. And that's the combination. I'm not saying that 3D printing is not valuable. It is. It's very valuable. But the combination of Vesalius 3D with 3D printing, especially in a PluriView VR, is very, very, very powerful. You have best of both worlds.
See, one more thing is that you don't have to wait for the 3D printing parts to come back after printing. You can still interact with your model. And one of the advantage or more feature is that right now I am seeing in 3D. Suddenly, if I want to look at this model in 2D, all I have to do is just raise this up. Now you are in 2D. It's just like a normal monitor. And suddenly I can just put it back. Now it's 3D. So the technology that works is a passive, because if you are working for hours and hours on a data set, you will not have any problem with your eyes, especially with when you are visualizing in a active shutter glasses. This is another stereo technology where you have flickering glasses that will actually make you tired when you actually look more than 45 minutes. Here we can minimize that tiredness. Still, you can work for more number of hours. For example, the radiology. If you are getting data sets and continuously, if you are getting for like you want to work for so many data sets, if you are expert in that, you can very well see it like a normal, very smooth and very interactive stereoscopic interface.
Srihari, sorry for interrupting again. Do you have, I know you have many types of PluriView in your office, but do you also have the reflective balls, the VR, the PluriView VR available here?
No, currently we don't have a VR PluriView in India, and I think it is going to be shipped soon from Germany. And currently we have all other models. For example, like I would say, there are a variety of options you can look into 3D PluriView and Vesalius together. Vesalius is a software which we can put it into any of the systems, computer. Only requirement from our side is a graphic card.
Right.
And this is a 22-inch monitor, and we have 24, we have 27 and 28. 22 and 24 inch are full HD resolutions. That is, each eye you will get full HD. And 24 is also full HD, and 27 is 2.5K resolution. 28 inch is a 4K resolution per eye. And we have the augmented reality PluriView or virtual reality PluriView, that is 8K resolutions in total. And that is how we have variety of dimensions of the screens available to best suit. For instance, if you have a small space, you can actually take up the 22-inch with a Vesalius software into it.
Right. And for us as a company, I mean, we have a long working relationship with Schneider Digital. For us, it's a very good thing. I mean, we used to make our own 3D workstations in the past. Thank God that Schneider Digital exists, because it's their headache now. But it's an additional means of showing for a doctor, showing your 3D data, showing your DICOM data. So don't get us wrong. I mean, Vesalius 3D is available on every laptop. You can use your own laptop, so a regular 2D screen. You can use Vesalius 3D on a VR station like the VR PluriView. It's available for there. But also if you're in a large hospital, and you have a theater where you want to sit with 100 or even more people. We have had sessions for up to 2,000 people where everybody was sitting in an audience wearing their 3D glasses, and the doctor was explaining the case to the audience.
Yes.
It's a very, very, very powerful tool to communicate and have people interact with each other. Mark, I would like to get you in, and also maybe for you, Srihari and Joseph and everybody in this interactive session. We should stick a little bit to the schedule, I guess. I mean, there are some specific topics. I mean, we did some 3D printing and everything, but there are more topics and more people that come in for specific topics. So I want to give my session back, basically to Mark and Joseph and you guys who are doing the next sessions. Thank you. If there are any questions, please come to our booth. That's another thing I would like to say. And finally, something that has been said before, but people that are interested in using Vesalius 3D, who are interested in using and trying the software, there are demo licenses, trial licenses available for a 3-month period. So, and you also, if you have your questions and specific issues, or how do I do this or whatever, we are also available to answer that. Go ahead, Srihari.
Yeah, this is the same thing.
We have already some questions. So if you check the discussion panel, Arian.
So this is one of the things we were talking so much about, the software and hardware. How can the users or the doctors can use it? So you very well answered about that. We can give up the trial licenses, and also our PluraView is always there in Bangalore, Tamil Nadu. We have in Hyderabad, we have in Mumbai, and we have in Delhi, where you can raise a request, and surely we can give you the hardware and the software together with you.
Just again, the earlier question about a maxillofacial, a cranial CT. Do we have something like that, Mark?
Yes. Can I get into this?
Yeah, sure.
Yeah. Okay. So basically, I will go into the presentation mode then, and let me go into the presentation mode. So, do you see my my screen now?
Yes, now it's full screen. Great.
Yes, full screen. Okay, excellent. Right now, I'm going then into this data set, and over here I just loaded a data set, and actually I went into our little research in our research projects. One of the projects we've done is basically a fibula to mandible operation procedure, but basically it means it's the reconstruction of the jaw using a part of a bone from the leg. And one of the things we have to do is basically be able to show extractions from bone, but also from skin, and also from basically the muscles around, because it was those are operations where part of the bone, including skin and muscle and nerves, are being moved from one part of the body to another part of the body. What I wanted to show you here is how do we basically would make an extraction from either the surface of the face, as well as making an extraction from part of the jaw. So I just uploaded this data set, and I want to show you what we have here. So basically we have a patient here, and suddenly you can also see that by putting a CT together, you're almost getting into a situation where you start recognizing the patient. And in this case, we have a patient here where we can do this. And what you can see suddenly is we have more the surface of the face, but I can also go more into the bone. And I say, I want to show you suddenly this part of the data. Now I made a few extractions while Arjen was talking. And I said, you know what? I'm interested in this part of the data. So now I'm capable of putting this to a 3D printer and being able to send this or and use this further on. But I can also say, you know what, I'm interested in making extraction from an extraction, and I'm using that extraction part too. It's this part. I don't want to see this, and I say I only want to use now part of this data. So I'm going to make an extraction from this one and say, okay, this data I want to keep. Love what I have here. I don't have to do anything there. And I'm now using my scissors to cut a piece off, basically. So I say I want to keep shape, and I'm cutting. I'm just using a knife here. And I say, this is what I want to have. This is what I have. So this is now a piece of bone I have extracted here. So this part, and I'm making another surface out of this, and I said this is a detailed surface. And I have this part now, and I'll give it a nice bright color. So now I have this data set. It's part of that jaw is located there. I would be able to extract it. I would be able to make a mold of this, to use a cutting mold of it. It doesn't really matter, and I can do these things. But on top of that, if I want to have the shape of the face itself, yeah, I'm capable of saying, okay, you know what? Put this one on, yeah. And you can still see there this little piece of bone is over there. But on top of that, I made an extraction of the face itself. So now I'm capable of basically sending this to a 3D printer, and you don't have to go to Michelangelo anymore to create a beautiful statue of a person. And here we have it, and it's completely, and this way you are capable of extracting several segments out of a data set and use them side by side, because it doesn't really matter how many you have, you're capable of using them on the fly, basically. So that is something that came. I hope I've answered the question that was coming to us from the specific visitor to this session. So this is what, yeah. And the next question is, can we use CBCT data? And so if someone can, here, CBCT data, I have that. That's a dental scan, if I'm correct. As long as the scan contains volumetric data, we normally are able to use that data directly in Visualisation 3D. There are always different kinds of models that are not yet available to us. However, so far our experience has been that we've been able to do almost anything. But if a scan is just a surface scan or just a one slice scan, then there is basically no point in uploading it into 3D. So that would be the little answer to that one. So this is an example of making extractions of a cranial area. In this case, not the cranial, but I use the jaw over there. And we have a lot of other kinds of data sets as well. So let me now go to a data set where you can see a stent. So there is information in the scan that is not part of the body, and how well it can be visualized there as well. And what the types of data we can use with Visualisation 3D is not only CT, MR, PET-CT, but we have also been working with a lot of microscopy data from other departments in the hospital. So we have actually used many of the available data set types that are available to us. In this case, here we have a scan of a patient, and you can already see very well that there is a stent here available. And let me highlight this a little bit better for you. If there are questions coming up, then I would love to see them. So, and here you can see very well how this is all correlated and where it is within the patient. And let me show you the patient itself. And now you can see where it all is. I would love to open up now a scan of another part of, and you can see here where the big problem area used to be. But now I'm going to open a data set that is really interesting. I think it is a data set where there is a coarctatio, and it's a huge one. So. So Arjen already showed that there was a possibility of using ultrasound data, and the ultrasound data is actually often 4D. We're now also in different projects where we're extracting, for instance, scar tissue in the heart, where we're using specific settings, and we work there with manufacturers of the scans. And so here we have a very beautiful data set. This data set, anyone who has a little bit of anatomical knowledge knows that there's something dramatically wrong with this patient. Yeah. In this case, if you look over here, there's a huge split of the aorta. And if we go and fly into this patient, and we'll move this data set a little bit around. Let's go over here, and I'm going to go in here, and we can see this very well. You see this patient has had an operation. If he goes over here, you can see the stitches. And if you want to see what kind of stitches they are, I will show you the metal. And suddenly you can see that that is the work of a previous doctor. And now I'm showing you here, and we're going into this patient. Over here, and zooming in. And suddenly we're flying through the patient. And what we have over here is a huge coarctatio. And over here. So suddenly we see this split, this rupture in the aorta. And we can actually see where the rupture and where the problems have appeared. And anyone can see here that this is the original aorta, the real lumen, and the false lumen is over here, that most of the blood flow is going on the wrong side. Now, what you also can see then is where are all the connections there to that are relevant. Which vessels are coming now out of the false lumen and which vessels are coming out of the real lumen. So this makes it possible to really see that and really visualize that easily. Well, I'm working behind my laptop. Unfortunately, I don't have the PluraView at my disposal at this moment to work with. So now, if I'm here doing this, using the PluraView, it's even 100 times easier to do this. So here you see this little rupture, you see these vessels coming out, and you can immediately see and understand the anatomy of this specific patient. Finding out that these vessels are coming from the false lumen using a 2D scan is virtually impossible. Now, if I'm now going over here, I'm now going to show you that we can actually fly through the data set. And over here, we're just looking into it. and suddenly we're in here. We can do this, and we can really see what is inside this patient. Doing this, and now I'm going to make it even nicer. I'm going to maximize the screen, and suddenly we're in here. These are all tools that are standard available in Visualisation, and all I'm doing, I'm just fiddling around and I'm just flying through the data. And because we have the ability to immediately go in between data sets, visualizations, we are always able to, if I don't understand where I am, I can readjust it and immediately get back to a nice understanding of the data.
Mark, can you hear me?
Yeah.
Okay. Maybe for the audience, one thing to add, and I know it has been said, but I want to emphasize it. We are not medical doctors. Even Mark is not a medical doctor. We've been working on this and have been doing this for a long time. So we've spoken to many doctors, but we're not medical doctors. It shows, however, that the moment you use an application such as Visualisation 3D, where you can actually see what the problem area is and how stuff is related and connected, it makes it, even for non-specialists, which we are not trained doctors, even for non-specialists, it makes it very easy to understand the problem. And that's something which is important. It's important in group discussions where there are specialists from different sides of the table. For example, a radiologist, they're very good in flat images and they understand the images because they're doing reconstructions in their head. But for example, surgeons are far more 3D oriented. They are operating, they're doing surgery on a patient, which is by definition a 3D object. So if you have a complicated case and you need to discuss it among different type of specialists, then especially a 3D visualization makes it very helpful. What we see here in the Netherlands as well is that, and also with our customers in the world, is that explaining a 3D case to a patient. I mean, you can use, people make drawings. This is your problem. You can use a flat image. Yeah, you see a problem. But people truly understand it. And I mean, truly understand it the moment they see their body, the problem, and how things are related. It's very, very powerful. And parts of the comments that we get back from our customers is that patients understand it better. So they don't need a second consult. They don't need a further explanation. They take the data with them to their homes. They either have a program like Visualisation 3D, but also in the communication with the doctor, the moment they get, for example, the bad news, it is shown to them. They understand it better, and that helps the whole treatment process. That's something I would like to add, Mark. Please go ahead.
Well, thank you, Arjen.
Just one question, Arjen. You said the patient can take the data home, and they would have Visualisation at home. Is there a free license of Visualisation?
Yes, and it's a good question. Thank you, Stefan. We have currently, we're in the process of changing our business model. And the business model right now is that we have a different price scheme already for patients. Patients, we offer it right now for €6 per month. However, we're going to change this. In the future, Visualisation 3D, the basic version, will be free. It will be a free software license. Of course, not all the functionality will be available for everybody. No, I mean, we still have to make some money over here and pay salaries every month. That's the way these things go. But Visualisation 3D will be in its limited light format, will be free, available for download on the web. It will be a fully maintained software application. So our developers will be maintaining it. It will be there. It will be top notch. you don't have all the functionality. For example, we went in the previous session of this interactive meeting, we went over 3D printing, for example. That will be something that you have to get a subscription mode and pay a monthly fee. It will be limited amounts. Again, it will be a couple of euros here, a couple of euros there, but the model will be changed. And especially, to answer your question, for patients and people that want to use it in a limited way, so for 1 patient, 2 patients, 3 patients, they can use it for free. The moment you want the true functionality like 3D printing, the VR settings, 3D interaction, you want to have extractions, you want to connect it to a PAX mode, we get different models for that, different pricing models.
Great.
Mark?
Yes. Well, in the meantime, I was just showing you something else on screen that says, well, I was still sharing it. I decided to, because we have been looking at some data from the thorax area, we have seen some vascular information, we have seen some stents in this session. I wanted to show you also that if there are very complex fractures in, for instance, in this case, an ankle, that the benefit of not having to go through your normal scans and understanding where are all my my fractures, and I want to see where they are and how they're all correlated, that by getting the information into a true 3D model, and basically this is not the model because it's the real data, but being able to get that the understanding of what's wrong is so much easier, so immediate to anyone, that what Arjen was saying, that he mentioned that we're using, we also have a patient version available for Visualisation 3D. But that is because we get a lot of questions. And the questions are always, I don't understand what's wrong with me, and I want to understand it. I have to explain it to other people. But that's also the same question that a lot of medical professionals have. And they come to us and say, I want to have the best possible way of preparing myself for an operation, giving the best possible way of understanding the data. But on top of that, I need to explain it not only to my team, but I need to explain it to my patient as well, because my patient is more and more demanding every day. And they use this also to in several universities here in the Netherlands in the classroom. They definitely want to use this, because understanding radiology data is extremely difficult. But any tool that allows you to basically go back to the real patient, and of course it's not a real patient, but the ability to understand the data intuitively is something we want to, that's why it developed Visualisation. And although it's still medical data, it's complex data, we want to make this data so easy that anyone with limited knowledge can understand what's wrong with it, but definitely anyone who's been explained to what's wrong with it should understand what it means. And that's why I wanted to show you this fracture. I can here make an extraction of this part of the fracture. We can focus on it. We can, as we already said, we can send this to a 3D printer. But the ability to show this in correlation with the rest of the medical data, the rest of the patient's anatomy, that's the real power we have here within Visualisation. And I would love to leave it with that. And anyone who has has questions, they're free to contact us. And especially if they have their own data and make it difficult, because the moment you have data you don't understand, we'd love to work to assist you. And I see Arjen raising his hand, so I'm going to give it back to Arjen.
Thanks, Mark. We had a question coming in if Visualisation 3D is 510K cleared. It's medically certified in Europe for planning purposes. So that's the answer to the question, and it's not yet 510K cleared. That's a choice that we made not to do it. First focus on Europe, and the US will come later. I would like to add, so just look over the questions maybe, Mark, if there's anything that we missed. I would like to show the audience a presentation that we have and is available in the booth. Just asking everybody if they can say yes, please. Can you see my presentation? Am I sharing it?
Not on full screen.
Not on full screen. Okay. On a little bit limited screen, doesn't matter. I'm going through it.
It is almost impossible to read.
I think it is Mark. Mark, you can. You're as a moderator. Maybe you can put Arjen's presentation in the full screen mode.
How do I do that?
Good question.
No, let me go.
I think if you double click, it'll be there.
I double clicked it.
It's bad, but let me just go over the points I would like to make. Some people are not being able to read it, but I can explain it. I mean,
Mark, are you still in presentation mode?
No.
No? Okay, because I still get you full screen.
So
I think if you double click on Arjen, you can still get a full screen.
I did. Yeah.
Okay.
Okay. Now it's changing. Now it's back. What happens if you switch off your camera, Arjen? Mark. Okay. Now we get your picture.
No, he's looking good. Okay, let's try and present again, gentlemen. This is just
okay. That's better.
It's better.
Yeah.
Okay. Just the point I'd like to make to emphasize it all. I mean, I'm real quick just to finalize this session. People have been interested in how the human anatomy is and basically functions for a long time. So it's not something new. The thing that amazes us as a company, really amazes us, is that doctors are still looking at it on flat slices. I mean, we have all this beautiful scanning technology, and we're still looking at it on a flat image, which is not smart. I'm saying that it's not smart. And the thing in a combination with Vesalius 3D and a 3D VR PluraView, it makes it very, very, very more intuitive, and you can see the whole surroundings. You can see, basically, even if you don't have an education, as I just explained, not a medical education, you can see the problem areas. We see a couple of trends, just to tell the audience what we are focusing on. And some of the stuff has been mentioned already. We see explosion in medical data. There is more and more medical data. We see medical professionals dealing with this data. We have trainers and educators, and especially patients. They're more involved in their whole disease and how they want to get better.
Arjen, just a quick one. Just for the audience, if you still get just a small picture of the presentation, click over with your right button over the presentation that Arjen is giving just now in the small preview picture. If you right click, you get a picture-in-picture mode. And with that, you will get a bigger screen just in case you can't see the presentation on the full screen. Now it's on the full screen. Okay.
Beautiful.
Whatever happened.
You're a technical guy,
now
Stefan. You're the technical guy here.
Sorry to interrupt.
No. Don't worry. That's the way we are. We are interactive. Also, this presentation is available in our booth, just for the audience who wants to download it. Our mission, I mean, every company has a mission, but we truly feel that we have a value to help doctors and patients for a better understanding, better treatment planning, better informed teams, and in the end, better treatments, better patient outcomes, and better care. That's what it's all about. I mean, that's what everybody that's working in the medical field, that's what they intend to do. We've been working around and working with Visualisation 3D in the Netherlands specifically, but also in Japan and in Europe in several instances. And we have specialists that are our key opinion leaders and have been supporting us for a long, long time. So we started the company in 2005, which is a long, long time ago. And right now, I mean, we're in a good position to have developed it to a certain level and still continue develop the software with key opinion leaders and our specialists in the field. So it's not that the technical team has figured out something and this is the way we're going to do it. No, there are thousands and thousands of hours of medical specialists involved in the development. The right thing, and this is basically the combination between the 3D PluraView and Vesalius, is that it's not only showing a data set in a proper way, but also making the selections. Go to the right image fast. Make sure that it works for you and do it in an easy, intuitive way. And next time or in a session where you ask us to, when we're on one-on-one, we'll show you how easy it works with holding the balls and having two-handed interaction. That's even more easy. But as you figure out, and please apply for the free version of Visualisation 3D, you can use it on your own laptop, and you figure out how easy the controls are, the mouse and the keyboard. It's also very intuitive, but not as intuitive with the VR PluraView. This is, I mean, we've been around. We're very good as a company. This is the part that we shown you. I mean, some of the functionality we went over today. This is a screen that I want to show you definitely. The use cases we have in the Netherlands are a variety. Basically, and I say it very, very short, everybody that's a user of 3D information and needs the structural information of a certain problem. It's quite often that you can see, yes, there is a cancer in the lung. Yes, I can see it there. But to treat it, you need the whole structural information. You need the whole patient because you have to approach this area. And the moment you only have the problem as such, but you don't know how to get there, then you still have a problem. And that's especially where applications such as Visualisation 3D come in really, really valuable. One item that we already mentioned is radiology and people in cardiology. They're very good. They're very good in what they do. And because they've been to school for many, many years and they know how to read 2D images. Even of 3D structural data, they know they can look at the 2D slice and especially at a stack of 2D slices, and then they can create a 3D image, and basically they do it in their mind. The rest of the world is not so good. So what we see in the Netherlands, that people in radiology departments, they use it to explain problems to other specialists. We see it happening in team discussions where there are different specialists and you need to discuss and look at it from various insights and from various expertises, that people need the 3D imaging to explain it to each other. That's also where 3D printing comes in very, very, very handy. If you have a problem area and you can hold it in your hands, these are the type of thing that people are looking for. They are holding an item, which is a printed item, but basically it's a patient. And in a little while, they're going to operate upon this patient. And being able to do your planning in such a way that you are more or less prepared on all the problems that you might encounter, that's very, very, very valuable, and that will be the future. So we hope to be part of this future. Again, we've been around, we're working with many hospitals and doctors. in the Netherlands. We're an SME. We're not really big, but with 10 people, happy to work for you and work with you. So yeah, this is where I want to stop the presentation as well and hand over the microphone to Schneider.
Thank you, Arian. That's a great presentation. In the discussion area, I found 3 tabs. One was audience, one is a private panel, and one is a question and answers. And one of the answers there, question is, could we use educational video demonstration proposes? So may you check also those questions there. And then we have to think, because this plenum, I think, is we have still 20 visitors there, so not sure if we what we can show here.
Joseph, just I mean, some of the questions, I'm reading through it, and Mark, please put your microphone on as well. There are some questions. Let's see. Because I saw a question, HoloLens, can we use it in the HoloLens? The answer to that is yes. Are we selling that at this point in time? Now, maybe I shouldn't answer yes. We have had tests where we use it in the HoloLens. So we have been working on that in several projects. Do we have it commercially available? No. We don't have it. So that's a basic answer to that thing. We're always interested in looking at different displays. So whether it's a VR PluraView or a HoloLens or some other lens-specific lenses, we have projects here. Mark can go into more detail about that, where there is a high-tech lens where Visualisation 3D comes into that, where a doctor can use that during surgery. During the surgery, he can have a look at the patient by sort of magnifying glasses, and at the same time, he can have a 3D model of Visualisation 3D in his glasses, so he can compare and sort of navigate where he wants to go. Is it commercially available? No. But it stresses, and that's the point I want to make, is that we as a company, we're always willing to think with you. I mean, if you have specific items you want to address, or research cases, or R&D, please mention it to us. Commercially available? No.
Arian, can I interrupt?
Yes, please go ahead. Yeah, go ahead.
Okay, I see the questions there. I'm going to say it a little bit differently. HoloLens right now is no. Yeah. Surgical glasses to be able to visualize Visualisation 3D while operating using surgical magnifying glasses. Actually, that's a project we're working on right now, and the product is going to become commercially available pretty soon because we're testing a new OR right now. So that's not really a HoloLens, but basically the next step beyond the HoloLens. And we don't want to make a cool feature. We want to make something that is actually in use and very much available. The second question I've seen there is, so stereoscopic projectors, 3D TVs will be supported plug and play. Answer to that one is yes, it is, because we have used many 3D TVs. Unfortunately, it's very difficult to find them nowadays, but there are still 3D medical TV, but 3D projectors, and that's a business that Schneider Digital is very much specialized in as well. Yes, Visualisation 3D works out of the box immediately with those systems. That's the advanced version of Visualisation 3. That's the Visualisation 3D VR version that is available there. And it works straight out of the box. And even more beautifully, it works then also immediately with 3D interaction devices that you can use. So that's great.
Mark, can I add one thing to that? Just a little narrative. In the past, we had 3D monitors that were commercially available to the general public. 3D TVs. I mean, everybody, not everybody, but people bought them and to put them in their house. That business is not there anymore. People are not buying 3D TVs anymore.
A lot of the 3D televisions are still there. So even
but
for
Joseph, not that work with our Visualisation 3D. So that's where the problem area comes in. In the medical field, you still see the 3D medical screens. If you go, for example, to a medical expo, you find them. They're more expensive screens, so they range in the thousands of euros, but they work with Visualisation 3D. So it's still available, more expensive, but it is there.
Is there like a resolution limitation? I mean, can we use Visualius with an 8K display if we go to a very large display wall, a VR wall? These VR walls today, they can go up to 20, 30, 40 megapixel displays because they are very big. Is there any limitation that what Visualius can show?
The limitation generally is the GPU and what you're running at.
So it's at 16,000 by 16,000 pixels. This is the OpenGL limitation. We can run Visualius and all other quad buffer stereo application we support. So more than 300, is on your list, and all of them are limited to 16,000 by 16,000 pixel.
That would be a 200 megapixel display.
Yeah, so that's still enough room.
Okay.
So, but it's basically the limitations are all from our end are on the GPU side.
Okay.
Yeah.
Maybe if the audience still allows, some of the audience have not been present with us when we started the presentation. Maybe I can briefly go back and just show a couple of slides of the PluraView. And I also have this very nice live presentation where we see Visualius with the PluraView.
Yes, with
the video, correct? I have that also. So maybe I'll switch over to the presentation mode and see if I can just go back briefly into a couple of slides for the audience who has not joined us in the beginning. See the screen? Is it?
Yeah, not full screen. So you should use again. Now it's full screen.
Okay. Just let me go briefly back through this presentation. Introducing Schneider Digital, introducing Visualius. We have a lot of experience with the hardware. This is the lineup of the previously available dual screen passive stereo monitor, starting with Planar back in 2005. And we took over this dual screen passive stereo business from Planar in 2015. 2016 came out with the further developed PluraView series. They are available in two sizes. On the left is the 22 and the 24-inch models, which are very compact. On the right-hand side are the 27 and 28-inch models, which are also available with the VR tracker. So they are fully VR compatible. They are ideal, the bigger ones, for group presentations, for group viewing. The smaller ones are, of course, perfectly okay for individual work on the desktop workspace. The PluraViews are available in full HD, 2.1 megapixels and 2.5K. That translates to 3.7 megapixel displays, and the 4K is a staggering 8.1 megapixel display. So each panel has 8.1 megapixels as a 4K model. And of course, with dual screens, you get the full resolution for each of the stereo channels. This is just a side view, front view, and back view of the monitors with some sizes. This is how they would look like on your desktop. The smaller ones are 33 centimeters deep. This is the foot, and the other ones are about 50 centimeters deep. So they are still a good size for most desks, I would say. The principle how they work, displaying one of the stereo images at a 45-degree polarization and the other of the stereo images at a 135-degree polarization angle. 90 degrees is in between, and these 90 degrees is basically the images are displayed cross-polarized, which enables the stereo channel separation for each eye. So that is as simple as it is. There's no battery involved. The glasses are very lightweight. Srihari has showed it earlier. They are really very light and robust, and you can wear them over even your prescription glasses the whole day, and you won't even notice them. The big advantage is it's daylight suitable, so you can work with them in the normal daylight in a medical doctor's office. You can sit close to the window, and the images are still bright and clear because we work with 2 monitors and we have twice the brightness in contrast to a line polarized monitor, single screen monitor. Some pictures, from our many exhibitions that we usually attend to, and of course we would have also been present with you in India today if we had had the chance to travel. You see that many people can group around the monitors. They can look at the stereo image from different angles, different positions, further up, further down. It's a really wide viewing angle, which makes them so ideal for group presentations, for discussions in medical teams, and also, of course, with the patient, and maybe with the whole family of a patient. They can come and see this, and you've seen the presentation by Arjen and by Mark. The images on Vesalius 3D are so clear and so easy to understand. So I think this is a big positive factor using such a system. Schneider is, of course, not only limited to the small displays, let's call them the desktop monitors, but we really deliver complete solutions. So we can provide a turnkey solution with a workstation that we built from very high quality components, very cost efficiently. If you can go and buy an HP or a Dell workstation, but it is like you're going to a warehouse and you pick a suit from the shelf and try it on. Okay, it fits sort of, maybe not that well, but it fits. We are like your tailor. You come to us, we take the measurements. You tell us what you want. We want the buttons here. Sorry, that was a little bit fast. We want the buttons there. We will generate a solution that fits exactly what you need and your requirements. And we understand Vesalius software very well. So we know what is the amount of data that you will likely need, what is the amount of RAM, what graphics card should be put in there, what are your requirements. And you also see the handheld controllers down here. There are more handheld controllers for fly-through, for working in stereo. If you want to go big, we can also provide complete stereo walls. And this is an example of what we mentioned before. These walls are now regularly 8K, multiple stereo projectors, and they're perfect for big auditoriums, for university, for presentations. If you may want to have one in your lobby, as a matter of fact, and you will find that there will be groups of people standing around and watching the content there. So this is briefly the big presentation that I wanted to make. Let me just start the video. Again, we cannot show stereo because it's just a video, and you only have a normal desktop monitor. But it gives you more of an idea how it would look like when Mark would be working on the PluraView. Here's the video. Let me see. Are we getting to see the video?
Yes.
We see it.
You still hear my voice, or you hear?
Yeah, we still hear your voice.
Okay.
As well.
Is there music with it?
No music behind.
Okay, good. So I get the music in my headphones, but I think it's probably self-explanatory. So here you see the trackers. We can attach them to a scalpel, synergy knife. And you see the tracking mark on the screen, and here's the eraser that Mark was using before. The tracking sphere, and we can also use a foot switch. So the red sphere is the tracking sphere for the manipulation of the view, and the blue ball is for erasing tissues. So you see how it goes behind and in front of other tissues, how it erases part of those tissues. Now he rotates the view with a tracking sphere. So this is the display, what you would get. Okay. Oh, that's how it looks like, a typical desktop workspace. So that would be my part for those of you that have joined us later. And of course, please come over to our booth. We'll be happy to host you there and talk to you one-on-one. And yes, hope to hear from you. I think we're done with our presentation. Arjen, Mark, do you have anything else to add?
No, I think you did a fine job. Thank you.
I think you did a great job. Honestly, I can't stop watching this. It's absolutely fascinating.
I want to say great things that we have now this free cost license for patients. So that is we have to bring this up. I think we may have more marketing powers in Vesalius, so we should use our marketing to share this information to our resellers as well.
You can switch on your camera, Joseph.
Yeah, I can switch on my camera, sure.
Yeah.
We have a worldwide distribution network. So India is only one market we achieve, and that's a great news that we have this powerful software available for patient for free. And even for us, it's a new point that we can use the full version for hospitals with 3 months, and that will be definitely a business enabler. In the solutions, and with the feedback of the doctors and with your strengths in developing requests from users, we will bring up the software in a more powerful version very soon. Even you have already. What is the experience on your software? How long did you develop Vesalius software so long, Mark?
Well, as when we started out, we are a spin-off from a national research institute, and in 2004 we created the predecessor of this company from the National Research Institute for Computer Science and Mathematics here in the Netherlands. It's one of the top leading institutes over here. And we basically took over all the research projects in virtual reality, among which was basically the research in volumetric imaging. And at that time, it was a lot of volumetric imaging of microscopy data, the confocal microscopy at the time. And so basically, it has been in development for 20 years. So that's why there are already many things in there, and we started the development with one thing in mind, and that was that the user needs to have an experience that is as natural-like as is basically possible. So in that sense, we created an environment that is an immersive workspace, and we developed from the core using the power of a GPU and not the CPU. So that's why you see this extremely smooth way of working with the data and not the jittery processing here, even though we're working here remotely using laptops and we cannot show it to you live in this at the moment, but it is under development for 20 years.
Mark, if I may add something to it, yes, we started development with that in mind, you're forgetting one, and that's I should be able to use it. I'm the dummy here in the office, gentlemen. That means that things should be very, very, very simple. If it's not simple, I'm not interested. I'm working here with all these technicians that are very, very, very smart. And we work a lot with doctors. And one thing we've learned from doctors is that their time is limited and they're working towards an excellent result in the fastest way possible. So things should be easy.
And integrate.
If it's not easy, most doctors are not interested because they don't have the time. That's my role in the company. If it's not easy, I'm not interested.
Yeah. So, well, we started out with one saying, and that was, you don't want to have a PhD in the corner to keep your systems up and running. Yeah,
that's right.
That's something you want to get rid of as soon as possible. And so, and the beauty is with Visualisation 3D, what we have seen so far is that when we have users, some of the users, they say, oh, it's great, it's wonderful, it's fantastic. And then we see what they do, and they use 1% of the possibilities. And then if I show that to my technicians, they're disappointed. But basically, we should be very pleased because that user has found his solution and can use it consistently and works fast with it. Other users have different requirements. Some of them just want to see the vascular structure. Others have way different requirements. But Visualisation was developed from a broad perspective of we want to create a visualization tool that allows you to get to the right visualization and the right point of view extremely fast, and from there on, specializations were developed.
Yep.
I hope I answered your question.
Yep. So, gentlemen, Dr. Shibu here, and when Dr. Mark mentioned about users, so this is one session that we hold where we also have the user's perspective. So I have the opportunity to introduce you to Dr. Lalit Maini, who actually is one of the leading surgeons in the country. So Dr. Maini is also he's also the promoter for orthopedic surgeon training programs. So he's also one of the biggest institutes, Dr. Maulana Azad College in Delhi. So Doctor, if you have any questions, maybe you can ask. So as a user, what is your responsiveness based in terms of technology?
Thanks, Shibu. Am I audible?
Yes.
Yes, you are audible.
Yes, we hear you.
Thanks for an excellent presentation, both on PluraView and Visualisation. It's almost mind-boggling to get to know what all is possible today. And I think what I captured was an amazing thought from you guys that the surgeons understand 3D and the radiologists understands 2D. So that's what is my perception. And Visualisation plus PluraView is an amazing 3D perception. So now if I have to get convinced, or if my team has to get convinced to look at the Visualisation images in actual 3D, you can't do it on a monitor, as you have been sort of limited to show the same effect through a webinar. So I'd also put the same question in the Q&A, that is there a possibility of extracting the Visualisation image and seeing it 3D as you can see it in the PluraView? Because this application would extend to the OR. When we are operating complex tumor cases, we at times want to revisit the images in the same complexity which we saw in the pre-op. So we need that extension of the visibility in the OR. So it has to be beyond the PluraView. It has to be something which is more easy and flexible, maybe through an object viewer app or something. So does that make you understand my query?
Arjen, je bent niet te luisteren. Okay,
Arjen,
let me answer it, because Arjen has been blocking his microphone. A few things there. Yes, you can export the models from Visualisation 3D directly to any other application which you want to use. For instance, if you want to print it, there are STL models you can use to do that. Next to that, there are movies and screenshot functionalities in there, so you want to be able to. And on top of that, what we didn't show you is when I opened several instances of Vesalius data sets, you saw me and I was immediately at basically the right point of view. That was because in Vesalius there are states that basically saves the instance of Vesalius of a data set in a way you want to restart it and reuse it again. And that allows you to open it immediately in the OR, seeing it on screen as immediately the image you had before. And if you then want to do something with it, you have all the functionality available to you. Or you say, I want to have just a limited piece of information and just be able to rotate it, reposition it, or do so. But that's up to the user.
So if we have to actually look at the strength of PluraView, do we have a demo piece moving around in India which we can have a look?
We have 5 displays at the moment in India available, and Sri Hari is our represent in India, and he can arrange a demo with you. We have in Germany a strong workstation connected to the internet with we can give you already full access. So it's a private network. It's only you will get some access to this machine, and on this machine we have Vesalius installed. So you can try on this strong private cloud machine your data. And in the next stage, we can connect to this machine a PluraView, and we in Germany can check the stereo quality. But we will see in what is in the first stage more important. We can see that your data sets, your formats, your different ultrasound, MRT, CRT, whatever you have on content is already available in Vesalius. So I think that would be sensible to start first on a trial. And in the next stage, if everything in the software works fine, we give you then the physically hardware.
And the final concern of any buyer, what are the costs we are looking at?
So we have the Indian rupian costs in his mind. So Harry, you can share. I saw in the discussion you bring up 3,000. How many lakhs it costs? 3,205 Indian rupians.
So we have 5 different models. This is a 22-inch model. There is a starting one without the tracker. So this is a compact one. The price starting is from 3.25 lakhs. And we have 24-inch, 27, 28-inch. 22 and 24 is full HD version, and that is full HD per eye. And 27 is 2.5K resolution. 28 is 4K resolution. And in the video that Stefan has showed you with the interactivity, that is the VR PluraView. That is an 8K, 4K resolution in 28-inch. That's only model in 28-inch.
So nice, very exciting.
I will share you the price quotation.
Yeah, sure. Thanks for the exciting session and showing us where we are moving in 3D imaging and interaction and perceptions, especially in education and training. Thanks a lot.
Yes.
Mm-hmm.
Welcome.
Thank you so much, Doctor.
Shibu,
your microphone is muted.
Shibu, your mic is muted.
Shibu. Yes.
I think Aryan's mic took a break.
It was actually a very insightful session, and I think a lot of eye-openers. I mean, I'm sure with the kind of questions which are posted by the audience, I think there are a lot of questions probably which are still unanswered, so we need to continuously work together. And it's a pleasure to have Dr. Lalitji actually on the stage, because there are many questions which we can cover. We have a team of cardiologists who also work with us. So just to introduce ourselves, 3D Graphy is more like a consortium today that we've been able to build in the last 6 years. And we have doctors and surgeons who work with us very closely in 3D printing domain. But lately, it's been 7-8 months that we've also initiated our intent to look at 3D imaging big time, because I think both can be complementing each other. And because it all starts with content. The content comes with software and imaging first to begin with. And then subsequently, then we can create products and models for pre-op requirements or otherwise. So it's a privilege to have senior respondents like Dr. Lalitji and various other respondents whom we work very closely. And also, we see an opportunity to work together in the larger interest of educating and trying to see how we can institutionalize these technologies which can be user-friendly going forward to benefit. Yesterday, we had a chat. In fact, Joseph was there, part of a panel discussion. We had a neurologist who is one of the leading neurologists in the country. He was the first to initiate a case on neurology. So that was almost 8-9 years back. He says that cost is not the issue. We want the solution. Because for him, he says that's not what he's looking at. He wants the solution to be, adhered to in terms of ensure that you can get the solution. So I think there are a lot of quests, and that's where we really act as a catalyst in this space. Thank you so much, gentlemen. It was really engaging, and it was a lot of information and insights that you shared. And we hope to work together as a team going forward, because I think information, knowledge transfer is very, very important. Thank you, Doctor. Thank you so much for your time, and all the gentlemen here. Thank you. And I would like to have a quick photograph, though we're not physically there on the stage, but we have a back end in terms of with the firing smile. I will just take a click. So thank you.
All right.
Yeah. Thank you so much.
Yes.
I'm sure you guys are there till the evening. We have in the evening also acknowledging doctors and surgeons, the researchers and technology companies who are doing some great work through this 3D Graphy Medical Awards. In fact, we started this awards in the year 2015. That was under the umbrella 3D Printing World as an initiative. We had the privilege to honor Dr. Anthony Atala from Big Forest Institute. He's the first person to actually initiate on tissue engineering to make the organ liver, but that's still yet to finally getting implanted is always going to be a challenge. But I think the process is there. What we see, even in the morning, we had sessions on bioprinting and tissue engineering. I think there's a lot of things to be done in that space. But otherwise, I think there is a scope going forward. Bones are now printed, so that's another area. If you would know slowly and steadily, and Doctor would also second it, that there are materials like hydroxyapatite. And yesterday we had a very good discussion, Doctor. Thank you so much for that discussion, where doctors are also looking at HA coatings, when it comes to implant surface finish, which can be used for implants in orthopedics. So it was interesting to have all of these aspects covered in this 2-day program, and we did our best to do that. And it was engaging, and this is how we want to see that, how information can be rightly imparted through platforms like these. And Doctor, also, if you would like to, let me introduce Dr. Lalit Mani sir as one of the key respondents of also AR and VR. So he's also conducting a lot of sessions. Very recently, he was with Dr. Bruno, I believe. Doctor, he's also in touch with me. So we were discussing. You were actually a part of a discussion on AR and VR. So can you just broadly let us know, Doctor, what is the extent of these technology that you use within the institution currently?
Again, it's in a very infancy phase of applying AR for clinical applications, and the commonality between printing and AR is that the input is either from a CT or an MR. So the starting point is same, and if we combine them, they are actually complementing each other. And at this point of time, we are doing some testing research on precision placement of screws in the spine using AR and using the preoperative CT as the input data. And we're also using the AR platform to assist in contouring plates in trauma scenario to the patient-specific contours. These are certain initial research steps which we have started, thinking that probably 3D printing as well as AR are complementary to each other, and they start from the same starting point, which is the image. Let's see, next year we might be able to share something on this.
Thank you so much, and thank you, gentlemen, for being a part of this event. And we'll be there till the evening to then connect. And I'm sure the meeting rooms and the exhibition booths can be used for your one-on-one discussions. Thank you so much. Pleasure.
All right. Thank you.
Yes.
Bye-bye.
Thank you.
So we will switch to the booth, okay?
Sure.
Okay.